All right, I think it's about time. So, welcome to this talk, Creating Secure Software with Benefits from Cloud Thinking. I'm really happy to see that at least some people actually found their way down to this, hall. It was a challenge, right. So, good thing. We got to give you guys an awesome talk. All right, but before we jump into the nitty-gritty stuff, so who are you, Daniel?
My name is Daniel Sawano. I come from a company called Avanza Bank, which is a Swedish-based, internet-based stockbroker. And to give you an idea of how big we are, we're the biggest actor on the Stockholm Stock Exchange. And I spend my days pretty much, trying to write code, thinking a lot about architecture, and thinking a lot about how we can help developers create secure software. And who are you?
Well, my name is Daniel Deogun. I'm from a consultancy firm called Omega Point, that's in Stockholm, Sweden as well. I specialize in the crossing between application development and security. And, I guess you guys can Google us if you're interested. I think this is the boring part. So let's go into the fun stuff.
Yeah. So, security benefits from cloud thinking. That's the topic. What's that all about? Well, what we intend to talk about today is we're going to look at some design concepts and design ideas that is very common to find when you're building applications and running applications in the cloud. And then we're going to see if we can use those ideas to actually help us create more secure software and more secure architectures.
So you're saying that by using the concepts and design patterns that we actually find in the cloud, that can actually help you design better and secure software.
Exactly. And the ideas that we're going to talk about pretty much come from things like the 12-factor app methodology that you probably have heard of. If you haven't, you should look it up. You don't have to be able to read everything on this slide. And it also comes from the concept of cloud-native applications. And
So what's the real difference between a cloud-native application and, I guess, an on-premise application? Is that it? Or?
Yeah, exactly. But the thing is, all these concepts can actually be applied regardless of whether you're running in the cloud or if you're running on-premise, maybe bare bone, but maybe you have in some kind of cloud-like environment, but you're still running on-premise. They're still applicable, and that's the really interesting part.
Wow. Yeah, I'm really excited because when I read about these, when I first encountered them, I didn't think about security, and you probably didn't either. So this is going to be a fun ride, I think. So what will we cover today? We're going to start off by talking a little bit about configuration, right?
Yeah. How should we handle configuration in a secure way? And we're also going to look at some of the security challenges that you may encounter when you handle configuration in a more, traditional way. And then we're going to move on and see how the concept of separate processes can help you create more secure architectures.
And of course, logging. Everybody needs logs, right? And everybody deals with logs. But the funny thing is that these top three are actually, quite boring, right? But the concepts that we find in these are actually bringing us to a very interesting, challenging topic, and that's the 3 R's of enterprise security.
Yeah, and that's pretty much a radically different new way to think about how to handle enterprise security. And all the other topics kind of builds and works as a foundation to actually be able to do this. So that's going to be the end of the presentation, and I hope you guys will stay awake and stay with us until then.
All right, so let's jump into the first topic then, configuration. So what does it mean to store configuration in the environment?
Yeah, this is actually straight from the 12-factor app methodology, and the reason for why they have this advice or guidance is that you want to be able to build applications that are environment agnostic. You want to be able to build an application, then deploy it in a test environment, in a staged environment, and then, let's say, a production environment. And the application itself shouldn't be aware of the differences in terms of configuration between those environments. That's why you want to have that when you're running in the cloud.
So the application then is supposed to be able to run, sort of build once, run anywhere. You guys recognize that, right? Okay, good. So let's dive into a typical example, I think.
Yeah, so when you start out with a new project, or maybe you're doing some kind of proof of concept code, you start running code and then you need some kind of configuration. So you put that in your code, right? It could be like a port number to connect to service, maybe you need a timeout. And then you want to be able to run your application. So you put that in your code. So you put that in your code, right? It could be like a port number to connect to service, maybe you need a timeout. And then you want to be able to run your application. So you put that in your code. And that's fine. You want to keep it simple, especially in the beginning.
So this is like when you prototype something, you probably do this. I mean, you add your static variables like this, right?
Exactly. But then, after a while, you realize, okay, I need maybe a password to connect to that service. So where do you put it? Well, I already have my configuration in the code, so I put that in the code. And then you end up having this. And pretty much everyone here realizes that putting your password in plain text in the code is a pretty bad idea. But for the sake of the argument, and from an academic point of view, let's analyze this way of handling configuration from a security perspective.
And the thing is that this pattern of just adding stuff in the code like this is so easy. And unfortunately, if you have added all your other constants like this, adding those sensitive stuff sort of, I mean, you just do it. You don't reflect on the sensitivity of it. But let's continue the analysis for this, right?
Yeah.
Okay, so what are the challenges?
Well, the challenges are that since you're putting it in a code, anyone with access to, I don't know, Git or Subversion will be able to read this password, right?
Right.
Should everyone be able to read it? Probably not, but you can't access restrict a single file in Git, for example.
And it also means that everyone in your team is actually going to be able to see the credentials, the sensitive data, right? And there won't be an audit trail.
Exactly. You don't have a audit log that says person X looked at the secret or person Y looked at the secret and so on. Maybe you can see who changed it.
But the funny thing is that by putting it this way in the code tends to be redesigned very quickly, right? Because what's the real driver?
Yeah. That's a good thing, the lucky thing that we always end up having something else. And the driver is that we want to be able to deploy it in different environments, right? So what do? Well, you externalize it, and you put it in, let's say, a resource file. In this example, it's a YAML file, but it could be anything. So you externalize it, and now the application doesn't no longer know about the configuration, right?
Because each time the application is deployed, it loads the appropriate configuration for that particular environment.
Yeah.
So we've solved that problem now, right?
Exactly. Now you can deploy the application, build once and run anywhere, right? Now, if you look at it from a security perspective, it's still kind of problematic, right? Because just as when you put it in the code, anyone who can access the file still can read the password. Well, and not only, maybe you put this configuration in Git, but you also put it on the server, so now anyone with access to the server can just simply read the file.
To be honest, I would say you actually made things worse.
Yeah.
Because if it is in the resource file, it ends up on disk. And if it's on disk, well, maybe I should encrypt my data then.
Yeah, and that's a common thing you think about. What if I encrypt the password before I put it in the resource file? Then even if you can read the file, you can't read the password. That's a pretty good idea.
Right.
But what's the problem with that?
The next problem comes, right? What about decryption? Where do you store, how do you share the decryption key?
In another resource file. It's like the chicken and egg problem. So you created that new problem. So the advice is, if we take from looking at how you should do it in the cloud, they say, put the configuration in the environment. So conceptually, it's very simple. Let's say you have a Linux server, and you just inject all the configuration in as environment variables, and the platform will do this for you. Right? And then the application can simply read from that environment.
That sounds actually quite, I don't know, mind-blowing in a sense, because this means that I build my application. I can just fire it up in any environment, and it somehow gets the appropriate configuration just by magic, so to say, right?
Yeah, and why is this better for security?
Well, first of all, we sort of push the responsibility of audit trail from the application to the platform or environment, right?
Yeah, so since it's the environment that now handles all the configuration, first off, the platform can manage the audit trail, and also it's not going to be every single developer that can look at the configuration anymore. It's going to be a very small group of people, like the sysadmins. So you really narrowed it down in terms of the number of people that can look at the secrets. So
we could have a specialized team that only knows about this, and the development team that has a lot of, contractors or consultants that come in and out. We don't need to share the secrets with them.
Exactly.
Now, we could go open source even, right?
Yeah. Probably.
Yeah.
Now, one thing that we didn't solve is the issue with encrypting the password, right? Because the password is still going to be in plain text in the environment variable, so you can still read it, right? And, you know, how are the sysadmins going to handle the configuration? Maybe they'll put it in their own private Git and so on. So you still have that problem with protecting them. Now, one way we can solve that is by using ephemeral secrets, which is something we're going to talk about later in the presentation when we talk about the 3 Rs. So we'll come back to that topic later on.
Keep it in mind, ephemeral secrets, 3 Rs. Yeah, let's go there. Okay, so to summarize configuration, we could say that the way we address the problem of allowing you to build once, run anywhere, was to push the configuration into the environment instead and have it being provided to the application. And at the same time, we actually increased or improved the overall security of that application. But did you think about security when you did this?
No, the primary driver is usually you want to be able to deploy in different environments. So you got security as a side benefit, which is pretty nice.
Okay, that's kind of cool. So let's move on. Separate processes. I mean, what's that all about then?
Well, you want to be able to run your applications as multiple stateless processes. That's kind of like the elevator pitch, right? But if you break this down and see what it actually means, or before that, I should say the reason for why you want to do this in the cloud environment is because you want to be able to scale in and scale out. You want your application to be elastic, right? So
wait a minute, you're saying that by being stateless, it's easier to scale.
Exactly.
And why is that again? I mean, why can you scale a state? Why can't you be stateful? I mean,
yeah, because then you have the problem when you're scaling in. You can't just kill off applications, but if you're stateless, you can just distribute requests across all the instances. Now, if we break this down into 3 subsections, we can say that you want to run your applications as multiple stateless processes.
Mm-hmm.
And another thing is that you want to separate the process of deploying the application with the process of actually running the application.
Okay.
And then we're going to say that, well, all your stateless processes can't communicate directly with each other. They can only communicate via some kind of backing service.
Okay. I totally agree with this. I don't see the security connection yet.
We'll get into that soon.
Okay. All right. So let's start with the first one then. Run the app as multiple stateless processes.
Yeah. So again, we said that will enable you to add more instances when you get more load, and you can also remove instances. But when you're adding more instances, you're essentially ensuring that your service is available during heavy load. So it's available, which actually turns out to be good for security. Another thing you can do, since your applications are stateless, you can kill off an application instance at any point in time. So let's say an instance gets compromised, you have some kind of malicious software on that server, and the server starts serving corrupt data, like false data. So you lost the integrity of the information that you're serving. So now you can just kill it off, and then you maintain the integrity of the service as a whole.
But hold on. I mean, yeah, I agree. Still, availability and integrity, is that really part of security?
Okay. Those are 2 kind of important concepts, and they come from an acronym called CIA that is very popular in the information security field to help us analyze and understand the security risks. And we can actually use this to analyze security in software too.
How many of you have heard about CIA? And that's not Trump CIA, this is the other CIA. Yes. All right.
Yeah.
Okay, only a few of you.
Well, it basically stands for confidentiality, integrity, and availability. So what's confidentiality all about?
Well, it's quite simple, actually. We want to make sure that data is only allowed to be consumed by somebody that's authorized to be. And I guess an example would be your medical chart. I'm not allowed to read it, or only the doctors or whatever is allowed to access it, right?
Exactly. And integrity is about only an authorized person or system should be able to mutate data, change data, and it also means that if let's say I'm sending data over the network, it shouldn't be altered and tampered with in transit. I
mean, it makes sense. And then, of course, we have availability, right? And I assume that the data must be available when needed, or there should be in some sort of appropriate time at least, right?
The correct data should be available when you need it.
Yes. Can you give me an example?
So, for example, a non-computer science example would be, let's say my house is on fire, and I need to call 112 to get the fire department. But then when I'm calling, I just get a busy tone because someone is doing prank calls. Now, the service of 112 is not available, but it's a pretty severe issue because my house is burning down and maybe there's people in there. All right, so availability is really an important concern for security.
So that's the equivalence of some sort of denial of service attack, I guess.
Yeah.
Okay,
so the reason for why we're bringing this up is because CIA will help us discuss why something is problematic from a security point of view.
Okay, so let's jump back again to that, stateless processes. You said it was availability and integrity were the two concepts that were actually being promoted through this, right? Okay, and by being stateless, we are allowed to scale very easily, right? We can flex our system, so we can become more available. And if a service suddenly, gets hacked or starts behaving strangely, we can kill it off. We can shoot it down and fire up a new one if we wanted to, right? And that's also very good. It's the overall integrity of our system is being promoted. Interesting. Okay, let's move on.
So you want to separate the deployment and the running of the process. So typically, if you're hacking together some kind of deployment environment, you'll SSH into a server with some kind of privileged user, or maybe root, or maybe a sysadmin. You send over some binaries, and then you start the process, and then your application will run as sysadmin or root. So the problem with that is that now your application is running as a privileged user, so if your application gets compromised, then also your underlying server or host will get compromised, which is kind of a bad situation.
All right. Okay, quick question. Anyone running the app the same way, in the same user as you are deploying it? No? Of course not. Good. Very good. Because then it means that we can't actually escalate our privileges, right, if you hack it. Exactly. And to me, that's actually quite mind-blowing that you separate these two things because, the app most likely don't need the same rights as the deploying user. Right?
Exactly. But let's say you're running a web application. What do you need to do? Well, you need to listen to some kind of port, 8080 or something like that. You need maybe have write access to a directory so you can put your logs in there and, I don't know, connect to a database and so on. But that's it. You don't need anything more than that.
And in the security field, we actually talk about this. And we call it the principle of least privilege. And that's really what you should promote. And suddenly that makes perfect sense, right?
Yeah.
Okay, good.
So again, if you're running on a platform that already exists, it probably solves this for you. But if you're building your own system on-prem, you have to think about this.
Okay, then we have these back-end services. What's a back-end service?
Well, a back-end service could be a database. It could be a message queue or a distributed cache or something. Basically, it's a means of either storing state, because you remember your applications should be stateless, but it can also be a way to communicate directly with each other.
Okay. So you're saying you have microservices, for instance, and they don't communicate directly. They go via maybe the message broker or whatever it would be, right?
Exactly.
Okay.
Now backend services by themselves doesn't really improve the security of your application, but since your applications need to be stateless, having backend services is kind of a prerequisite for them to be able to be stateless. So it's indirectly improving the security.
So by applying the pattern of using separate processes, we actually get all these benefits, even though we didn't think about it. And this is the cool part.
Exactly. You probably thought about we need to handle huge tons of load when our application goes viral. That's what you're thinking about, but you should know that you're also getting all these security benefits. You're getting better availability and better integrity.
And the cool part is that you don't even have to be in the cloud. You can be on-premise. You just need to make sure that you're, if you're running containers or whatever you are, make sure that they're stateless and you communicate through the backend services. Okay, fantastic. So configuration and separate processes, both these two concepts from the cloud helps us implicitly to get more secure software, even though we don't think about them. Okay. Logging.
Yeah. The next big topic. Everyone loves logging. Well, some do and some hate it. It's kind of like a love-hate relationship. So the rule of thumb when running on a platform, a cloud platform, a cloud environment is to use logging as a service. And why do they say that? Well, if you're running, let's say, on a PaaS, a platform as a service, the file system is abstracted. The application shouldn't know about the existence of a file system, and therefore you shouldn't be able to write a log file to it. So you should send your logs to a service. That's the basic idea behind this rule.
I mean, it makes perfect sense, right? I mean, you don't know where your app is deployed in the cloud. And if you're honest, you could actually treat your on-premise environment the exact same way, even though you do know, but you can pretend you don't know, right? And then you can actually apply the same patterns that we're going to see here now, right?
Yeah. And a lot of time, what you actually do and what you see is applications are logging down to disk. And then, okay, maybe you have something like Logstash and you send it over, but still it ends up on disk to begin with. And the reason for that, I think, is because when you're developing your application on your laptop or your computer, I mean, you log to disk because you're just developing, and then you don't bother changing anything. You just move the application to the production environment, and you continue to log on disk. But there are several problems with having logs on disk from a security perspective.
Okay, so for the sake of argument, let's pretend that we are logging to a file on disk, and we put our CIA glasses on again, right?
Exactly. So what about confidentiality? Well, we're in Europe, so pretty much everyone here knows about GDPR, which means basically you have to be, you need to know what data is sensitive, and if you have sensitive data, you need to treat it certain ways. Now, when you log stuff, you know, we developers tend to put everything we have in logs because maybe it will be useful. So pretty much every log will contain sensitive information, and if it does, well, if it's on a file, you need to protect that file, right? You need control access to the file, who can read it, who can change it, you need audit trails and everything like that, which again is really difficult to do when it's just a file on a file system.
So by doing it this way, the traditional way, we would actually make sure that every log file has to be protected. And that's a whole lot more work than, you know, treating only the sensitive part as sensitive, right?
Yeah.
Okay. And also, if you have it on disk, I guess, from a confidentiality perspective, what if somebody downloads it and distributes it? How would you know? You don't, right?
Yeah.
Okay. So from confidentiality perspective, this is kind of bad.
Yeah. It's very
Let's go
unless your log, the content of your log files is completely innocent. Well, then you know, maybe you don't have to bother.
But the integrity.
Yeah.
I mean,
so integrity is something that is very often overlooked when you log. And basically, it can be, you know, who can change the file? If I look at a log file, how do I know that no one has altered the content in that log file when I'm looking at it?
But Daniel, come on, altering or modifying log data, who cares? The app behaves the same way anyways, right?
Yeah, maybe you don't care, but the thing is, if you're using your log as some kind of proof that something happened, maybe as an audit trail, well, then you need to be pretty sure that no one has altered it.
Okay. I guess if your logs are part of a court case,
exactly.
They're going to be evidence, right?
It could be an investigation for something criminal. And maybe you have regulations that you need to keep a good audit trail, and then you have your log file as an audit trail. Well, you need to maintain the integrity of that log.
Okay. I guess I didn't think about logs as something that you need to protect that way.
Yeah.
Okay. Interesting.
Maybe the log is some kind of transaction history and so on.
Okay. So that's also bad now from a CIA perspective. Okay. Availability then. If I log on, to a file on disk, isn't that always available?
It could be, or maybe not. Let's say you're running on some kind of virtualized environment, containers or whatever, and you're logging down to some kind of disk concept on the server, and then you kill that server, and you just forgot to move log files from that server, or Logstash didn't have time to send it over, then the logs are gone. And if the logs are gone, they're pretty much not available anymore, right? So you lost availability.
Right, and I also think that you might actually run into the problem of running out of disk space?
Yeah, because exactly, you might say, well, I'm logging to a mounted network disk, and I have huge amounts of SAW, and I'm safe. Well, and then you have this routine that the admins should rotate logs, move old logs to another disk that is cheaper, but you always forget, right? So exactly, how many of you here have experienced an application crash because of like insufficient disk space? I have.
Ah, come on!
We all have. It always happens. And when your application crashes, it's not available. So again, we know that availability is important, but we can have problem with availability just because the way we handle log files.
It's so weird though. When it crashed, I couldn't see anything in my logs.
Yeah, we tried to log the problem that we couldn't log.
Couldn't log that.
Yeah.
No. Okay. So I guess from a CIA perspective, logging to a file on disk is broken. I mean, that's a huge no-no. Okay. So how should we do it then?
Well, as the guidance says, use logging as a service. And the basic idea is really simple. You have a dedicated service that you will shoot your log message or log event to instead of just writing it to the disk. And since you have a dedicated service that maybe some of your development teams are working on, they have log file handling or log handling is their primary concern. So that system can now be really good at, let's say, exposing one API for sending log events to it, and any application can write to it. You have another API to read logs, which is very restricted, and since you only have that entry point, you can keep a really good audit log. And of course, you can keep the bad guys out. And another thing, since the log service is just getting one message or one event at a time, what if you want to digitally sign every log message? Then if someone has tampered with it, right? Because you have some kind of digital signature, and you can say, well, if that doesn't match, someone has altered it. So you have all these possibilities suddenly.
This is really powerful. If I understood you now, that we can make sure that only the applications are allowed to write to the log service. And there are only a few consumers that are allowed to read from it. And we could also partition our logs saying, like, this is audit data, this is allowed to be read by, that person or that system. And this is, system data, performance data, that could be read by these other ones. But they can never write to it.
Exactly.
Okay, and you can also digitally sign off your data, make sure that, if it's tampered with, well, because the signature doesn't match.
Yeah, and hopefully, since dealing with logs is a primary concern of those building the log service, at least I think the chance of someone forgetting to make sure there's enough disk space is minimized compared to when it was someone else's problem. So I think you reduce your risk of having reduced availability.
And from a CIA perspective, this all suddenly makes sense. Because now it doesn't matter if you're in the cloud or on-premise. You know where your log data is. And the nice part is that when your application dies or goes down, your log data is still, available, or at least according to the availability that's part of your log system.
Exactly. And then to make life easier, maybe you can make your log service more refined and separate something that is sensitive in some kind of audit log, and you have just a stack trace log, which is more sense. You can start working with separation of those, which makes life easier when you want to be GDPR compliant.
Okay, fantastic. So now we've covered the three aspects that sort of brings in different design patterns that makes your software better in many aspects, and also gives you security benefits as an implicit side effect.
Yeah. So these ideas by themselves will help you build better systems. But the cool part is they also, when they come together, they kind of work as the foundation for something called 3 R's of enterprise security, which is the next topic, which is really cool.
Yes.
So the 3 R's of enterprise security is something coined by a guy called Justin Smith somewhere around 2016. And he works at Pivotal.
Yeah, he's like the chief security officer or something like that, right?
And the basic idea of this concept is that he essentially says that since the tools and the possibilities that you have to create applications and systems in the cloud is quite radically different from the possibilities you have when you're running on a traditional system on bare bone. Shouldn't it just make sense that your approach to handling security should be equally different when you're running in the cloud compared to a traditional environment? That's kind of the basic idea.
Okay, so we need to be different. I'm not really sure what you mean by different, but I guess we'll get to that.
Yeah. So the R's, the 3 R's, basically stands for rotate, repave, and repair. So you want to rotate your secrets every few minutes or hours.
What? Okay, that sounds kind of insane.
It's going to be cool.
All
We're
right.
going to talk about this later. And you want to repave your servers and your applications at least every few hours.
That's like, yeah, you're saying like I should take my one down and bring up the same thing?
Pretty much, yeah.
Uh-huh. Mm-hmm.
And then you want to be able to repair, or you should repair, vulnerable software just within a couple of hours from a security patch has been released.
Okay.
And the reason for why this is so different is that we're basically saying that in order to reduce risk or make your systems more secure, you want to increase change.
Increase change? Wait a minute. I don't know about you, but I've been part of projects where you have people, they monitor your systems or systems of systems, and if there is a change, that's something bad, because now we know some intruder has come or something. So change tends to be bad in a security perspective,
you have
right?
all these processes, all these people looking at alerts coming from tools very expensive tools that you bought, and they all monitor change, and every time there's a change, you get an alert and say, hey, could be an attack here.
Okay.
But so you want to minimize change in the traditional way, but now we're saying, let's flip it. Let's increase change. And the reason for why we want to do that is because it's one type of attack called advanced persistent threat, which is kind of, you can say that it's the kind of attack that makes it to the headlines, right? The kind of attacks that will steal the really juicy data. And it's advanced because it usually involves advanced techniques. It's persistent because it usually takes place over a long period of time. It can take weeks, maybe months, maybe years even.
So you're saying that some malicious attacker would, install something maybe on one server, steal the token or certificate or whatever it could be, right? And use that against another system, install something there, and whatever.
Yeah, they try to find a different vulnerability and so on. And when you're doing that kind of, as an attacker, if I'm going to be in a system for several months, I want the system to be stable, right? If I find a vulnerability, I want to be able to use it for a long time. But when you start shaking things up and changing everything, you're kind of taking away the time aspect from the attacker. You're making it really hard to perform an APT.
So the gist of 3 Rs, I guess, is to shrink or narrow the attack window, right? We try to shorten the time someone can exploit something that they find, and move around as much as we can. And I guess that somehow makes sense, right? A moving target is harder to hit than one that sits still.
So let's look at the R's and see what they actually mean and how you should do it. So rotate your secrets every few minutes or hours. So let's start with a simple example. You have the password, that we talked about earlier. You have that in the environment because you learned earlier to put your configuration in the environment. Now you want to change that password, let's say, every 5 minutes.
Every 5 minutes?
Replace it with a new one, and the old one will be invalid.
Wait a minute. How often do you guys change your passwords? Anyone changing them every day? Okay, every week? Month? One hand, good.
Yeah.
Of 2? A year. Let's go for never. Okay.
We changed it when the company started.
So rotating secrets is somewhat, I don't know, that's somewhat
It sounds
weird.
like it should be something complicated, but if you place all your configuration environment, it suddenly becomes quite easy, right? Because now the platform can do that change for you. The application doesn't even know the password has changed. You just get the password from the environment and use it.
This is mind-blowing. Honestly, if the platform changes the password automatically, in theory, I'm saying in theory, we could create one-time passwords, right? Every time you use it, you consume it, it gets a new one.
Yeah. And again, pretty much every platform that you can, either if you're running in the cloud or you're on some kind of PaaS on premise, they can support this, or maybe they even have supported from, out of the box. But the thing is, Once you start rotating all these passwords, you realize that, well, if the password is just going to live for 5 minutes, then you don't have to store it anywhere. You just generate it, set it, and inject it into the environment. So it's just only going to live in RAM. Well, you never put it in a configuration file. So now you have ephemeral secrets. So you kind of solve the problem we had with the configuration file. You don't even have to bother encrypting the file somewhere, because it just lives for a very short time.
It also is funny that if someone asks you, what's the password to that system? And you're like, I don't know. Who knows it? Nobody. It's sort of AI, but not really.
Yeah.
The system knows what the password is, and it changes.
Yeah, and the whole thing with rotating is that you're minimizing the time window for some malicious user to use a leaked credential.
Okay. All right. So, but what if you have a system where you suddenly need to start caring about how passwords are changed?
Okay, that's a good point. And sometimes you actually, maybe changing the password or rotating the password involves some kind of business logic, or maybe it doesn't make sense to have the platform handle that for you. Then you can use a different approach or design pattern, which basically solve the same problem, where the application itself goes off to some kind of secret service that will provide the passwords, get the password, and then connect to whatever service you need.
So an example of that, I guess, would be the open source project by HashiCorp, the Vault implementation.
There's an example for on a service that can provide that kind of functionality. Right. And of course, it's not just passwords that you should rotate. You should rotate, if you have access tokens, or if you have certificates, you should rotate those too. Right? So one, the certificates that you use for HTTPS and all that kind of stuff. So if you rotate those automatically, now you can create certificates with really short validity period.
I don't think anyone has run into the problem of an expired certificate, but I see.
It's just I've run into it, but no one else.
Yeah.
You always have the problem that you forget to renew the certificate, but now it's automatically renewed.
So the concept of rotating is actually good because it automatically deals with the fact that expiry doesn't become a problem. Interesting.
Yeah.
Okay. Right. Repavement then.
Yeah.
This is kind of weird.
You want to repave servers and applications every few hours. Basically means that you want to create a known good state, which essentially means, like, if you're running Docker, you have like an image, or maybe if you're running a virtual machine, you have some kind of base image, and you can use that to create a new instance of a server. And when you recreate your servers, you want to recreate them from that known good state. And if you're running on a platform, they're probably going to provide you with the ability to do things like rolling deployments and so on. So you can create a new instance, kill off an old one, create another one, a new one, and kill off another old one. And you can do that without any downtime. So basically, you're just constantly replacing all your server instances.
But replacing it with the same thing again, is that really good from a security perspective?
Yeah, and the idea is that if a server gets compromised, when you burn it down to the ground and kill it off, you're also going to burn down the malicious software.
Oh.
Right, so you're making it harder and more difficult to perform an attack in your system, or actually trying to prevent the malicious software to spread as easily as it could if you're not replacing it.
Wow, so that's sort of also the integrity of that system as well.
Exactly.
Okay, interesting.
And one thing to remember is that if you have some kind of file mount where you put temporary files, you should remember to wipe those too, so you don't create a new instance and then just reuse those temporary files because maybe there's some bad data on those files. And again, if you run a Docker or some other kind of container, you usually run the containers on a host, which can be a virtual machine or something. So you should every now and then repave the host also, not just the containers.
But what if there are software patches coming out? I mean, like Meltdown was a problem, and the OS needed to be patched.
Yeah. Well, that's when the repair R comes in.
Okay.
Then you want to be able to get the patch, verify it, and test it, and then get it out into production. It shouldn't take more than a couple of hours. All right?
Okay.
And so when you have the patch, you verify it, you create a new known good state, and then you just apply the repave process and start replacing all your servers. Now, the challenge usually here is to be able to get a new OS patch in and verify it in that short time period, because sometimes it can take weeks to verify a new OS version before you want to dare to put it into production. So you really need to work on minimizing that time.
Okay, so if I understand you, what you said is that we find a patch available somehow, and we now need to run it through our process or test phases and whatever we do and make sure that it actually works.
Yeah. And some tips is that maybe if you can automate the verification process so you don't have so many manual steps, and maybe, for example, maybe you can utilize the fact that you're running on a cloud environment, so you can use concepts like green-blue deployments. Maybe you don't have to verify so much. You put in a new server, and if it doesn't work, you can just pull it back. You can use that to minimize your cycle time.
But I think the neat part here that you tend to, skip over or miss is that by repairing your OS image or whatever it would be, you don't do it incrementally. You do it, from scratch, right?
Yeah, that's a very important point. That at the end here, you can see you're using the repay approach. So you're not logging into an existing server and then apply the patch, because if the server is already compromised, it's still going to be compromised after the patch. So you want to repay, right?
And then we can use the repay phase in our system and our process by we have repaired this into a good state. It's there, and the next time the repavement comes in, it's going to get pushed out in your environment, and that's actually quite amazing.
Yeah, and the thing is, to be able to do all this stuff, you need to have stateless applications. You need to have your log files. They can't be on disk. They need to be in a log service. You need to have your configuration in your environment or somewhere else. Everything kind of comes together.
And as it turns out, one common mistake that many do is that you do have, if you're a microservice environment and you have old services there, things that are working fine. They've been running, for some time. But the fact is that they have dependencies that need to be upgraded. So you need to repave and repair your own applications as well.
Exactly. Not just the servers, but the applications as well. And, if you can make small incremental updates, basically if you're using continuous deployment, continuous delivery practices, that will help you to just push out new versions of your applications all the time. So, for example, it could be that you upgraded a third-party dependency, get it into production as fast as possible. Maybe you just made a little change in your code, well, package it and get it out into production. And again, the idea is that since you're always changing the application, what if there is some kind of a vulnerability in your app that you don't know of? Maybe, by chance, that vulnerability goes away when you change something. And then the attacker needs to find a new attack vector. So again, you apply the same concept on your own applications.
So I guess the gist of the 3 R's is really that ever-changing software is really the nemesis of persistent threats. And that's so mind-blowing to me, at least, that we need to move all the time in order to reduce the risk of a threat.
And again, sometimes this can be the complete opposite of what you're doing today, depending on how you're dealing with enterprise security. So it can be a challenge to make these changes, but we really believe that this is something that will help you deal with threats in a better way and a more agile way than the traditional approach, if you will.
All right. So we've covered, the concepts that we found about configuration from the cloud, the separate processes, and the logging, and the 3 R's, right? All of these concepts provided good design patterns to make our software better. But they actually made, improvements when it comes to security implicitly. It sort of made you security experts, even though you didn't know about it. Man, I really wish there was a book about this.
Yeah. And now is the time for the shameless plug that we're actually writing a book on this called Secure by Design, which talks about this and some other stuff which basically have the same basic idea that you can get better security by applying just good design practices in a certain way. And by doing that, we think it becomes more, available to an everyday developer. So you don't have to be the security expert to build secure systems.
So this is what we actually love, design, building great software. Security, well, that's not this fun, but it's needed. And if you really like that, what we actually have right now is a discount code that gives you 40% discount on this. Fantastic deal. Because is the book released yet or
No, it's not. It's not ready yet. We're writing the final chapters as we speak, and it's probably going to be in stores like this winter. But the good thing is you get the real book if you buy this.
Yes.
And you can actually get it's 40% discount off any Manning book.
So that's pretty good. Use this link if you want to, or go into manning.com and do it. This was our shameless plug, so we're sorry about that. And now we do have 5 minutes left for some Q&A, right?
Yeah.
Any questions? Oh, there's a question in the back there. I have a really hard time hearing the entire question, but did you?
No. Should we use the microphone maybe?
I'm so sorry. I think the last thing I heard was, how do you ensure that the repavement process actually increase security? Was that it?
The microphone is coming.
So my question is mostly regarding the repaving process. Is usually making you restart your application a lot. So you avoid the situation when you have memory leakage or some things like I don't know, buffer overflow somewhere in your software, and this leaves some potential vector of attack for somebody who is like malicious in your maliciously exploiting your software, yeah. And what will be the kind of a solution for it to make sure that you're still using the repavement, but you also secure all the stuff that you could actually find by monitoring your service for the longer period?
All right. So I do think at least the beginning of this answer, we want to make sure that we do something called security in depth. That means that we can't solely rely on the 3 R's and repavement. This means that we should have multiple layers of protection. And if your monitoring processes must also be aware of how your repavement processes and the entire 3 R's work. Otherwise, that would be, give you a lot of false positives, I guess. Do you have anything to add to that?
No, that's pretty much. And also that this is, of course, not replacing other good practices in terms of security. There are other things that when you actually are very explicit in what you're looking for to protect yourself, so you should still do that. But these practices are also good and maybe more attainable for those who are not security experts. So they complement each other. Was that answer to your questions? Okay.
Another question, maybe. I think there was a hand there. Yes.
Microphone.
So I never experienced this, like frequently changing passwords. How is it actually done? I mean, I changed the password to the database, or it's changed somehow, and then the application has to know it. How does it know it? Is there some technology behind it, or is there some master password system, or how does it work?
Okay, that's a good question. I think if you want to talk specifically about like databases, I think that's a unique case because usually have connection pools and all that stuff, right? And then I guess maybe if you can find a library that does it for you, otherwise it's going to be the application, and maybe you write your own library. So I think in terms of database connections, and correct me if you're thinking differently, I think that can't be handled directly by the platform if the application connects directly to the database. So you have to be application-centric, meaning that the application goes off and asks for a new password, maybe creates a new connection pool, replace that, and so on. But then another approach is if you're in the cloud and you treat persistence as a service, then you're not connecting to the database, then maybe you don't even have passwords, then you maybe have access tokens to connect to the persistent service. So that's another approach where you just remove the problem of handling the changed passwords from the first application's point of view. And then you can have a specialized, the persistence, the service that provides the persistence as a service is responsible for handling how should we actually change the passwords in the underlying database.
And the thing is that a lot of services are coming up nowadays that sort of facilitates secret rotation. And that if you're in Amazon, if you're in the cloud actually, Amazon provides that kind of service today. And it's sort of encouraged that you start using this pattern. But if you're on-premise and you say, well, I have my old systems, then you might have to write your own way of generating new passwords.
Yeah. And sometimes you need to be pragmatic. If you have like an old system and you can't just go and change it, then maybe you'll say, well, okay, instead of 5 minutes, I'll rotate the password every time I restart the application, for example. So you have to find, especially when you're dealing with legacy system, you have to do, try to manage what you have. So,
and you also need to make sure that you can't just simply replace the password immediately. You might have to have two passwords that lives along the side, sort of like a face in, face out thing, right? Because there might be services that have that, and eventually it will be distributed to all the services. All right, I think our time is up. But
if you want to ask more, just grab us after the talk.
Here, so please.
Thank you very much.